Hey everybody, this is Mr. Reeves with you again, and I'm going to be working through some of the IXL practice skills involving equivalent ratios. Alright, so just a quick reminder, a ratio is a comparison of any two quantities or two numbers, and we can write them using the word to, T-O. You often see them with a colon like they're doing here in IXL, or often we'll write them as a fraction. And equivalent ratios are ratios which, when reduced or simplify to the same ratio by factoring out common factors. All right. Again, I just want to encourage you, if you have not yet done so, to go back and watch the Khan Academy videos and do the Khan Academy practice before you attempt to do these IXL problems. All right, so our first question here, are the ratios 8 to 20 and 2 to 5 equivalent? All right, so I'm going to go ahead. Whoops, let's get that out of the way. I'm going to write them as a fraction. 8 over 20, or 8 to 20, and 2 to 5. All right, so if you look at 2 to 5, you will notice it does not simplify. There are no common factors other than 1. But if you look at the ratio of 8 to 20, I can divide both of those by 4, right? And 8 divided by 4 is 2, and 20 divided by 4 is 5. And as you can see, 2/5 equals 2/5. So the answer to this one would be yes. All right, let's look at a couple other ways we can take a look and see that these are equivalent. If you write them as fractions right next to each other, all right, if they truly are equal, we don't know if they're equal, all right, so I'm going to put a question mark like that. But if they are equal, there's this neat process called cross multiplication that will confirm that they actually are equal. If I cross multiply here, I get 8 times 5, and if I cross multiply here, I get 20 times 2. 8 times 5 is 40, and 20 times 2 is 40. And as you can see, 40 is equal to 40. So that is called the cross multiplication method for checking if two ratios are equal. All right, it's a nice, simple, easy way as long as these numbers aren't too big. The bad thing about it is it doesn't require you to have an understanding of why they are equal. All right, and another way we can do this, we can start with the smaller one, and this one's kind of fun. It's not a real practical way. All right, but if I have 2, that represents that one right there. I'm going to do that one in red, and I'm going to do this one in blue. 1, 2, 3, 4, 5. So that is my ratio of 2 to 5, okay? If I do it again, and I keep that same ratio, all right, what do I now have? 1, 2, 3, 4, 2, 4, 6, 8, 10, right? So I started off with 2 to 5, and then I went 4 to 10, and then if I did it again, 2 more here, 1, 2, 3, 4, 5 here. Now what am I at? Now I'm at 6, right? 2, 4, 6, and then what do we have? 5, 10, 15, and these are all equivalent. And if I did it just one more time, then you can see what we have. 2, 4, 6, 8, right? 5, 10, 15, 20. And you can see that 8/20 and 2/5 are equivalent, okay? 2/5 is the simplified version of 8/20. And if you watch the other video and you did the practice on just the ratios, not equivalent ratios, then you remember we had the total, right? We looked at the total ratio, and then we looked at one row, and 1 row represents the simplified version. All right, but those ratios are equivalent. All right, so again, this is not a real practical way to do it, especially if these numbers got super duper large, but it's a nice visual confirmation, right? This is simply 4 times as big as that. 2 times 4 is 8, 5 times 4 is 20, but since they are both 4 times bigger, then these are actually equivalent. So we would say yes to that. Okay? All right, let me skip up to the next level. Again, it's not any more difficult. Right here, you could see that 2 times 10 is 20, right? So this one is simply 10 of those. If I did a ratio of 2 to 1 and did 10 rows, I would get that one. So that one is yes. All right, what about if we skip up to the next level? 5/10 and 2/4. All right, again, I hope you can see 5/10 and 2/4. Let's do that cross multiplication method again, just so we can go like this and confirm, right? And what would we get? 5 times 4 is 20, right? And 10 times 2 is 20. And that would confirm that they are actually, excuse me, equivalent. All right? I'm not sure if these are going to get any more difficult. Select all the ratios that are equivalent to 6/5. All right, so 6/5, excuse me, could be written as 6/5, and then we have 48 over 40. Excuse me, let me make that 8 a little better. All right, then we have 5 over 6, and then we have 11 over 1. All right, I hope you quickly see that it cannot be 5 over 6, right? If you flip it over, the reciprocal will never be equivalent to the original ratio unless the two are the same, right? If the top number is bigger in the original ratio than the bottom one, it must be. All right, I hope you can also see it will not be 11 over 1. This number is not 11 times bigger, right? If it was 11 over 1, say if this was 5, this would have to be 55, right? Is it 48 over 40? Well, here's an example of one you would not want to cross multiply, but do you see that 6 times 8 is 48 and 5 times 8 is 40, right? So this one is yes and the other two are no. All right. Does it get much more challenging? Select all the ratios that are equivalent to 10 to 14. Again, if I have 10 to 14, if I have 2 to 6, if I have 27 to 42, and I have 60 to 84, and if I want to know if they are equivalent or not, several ways we can do it. All right, again, I encourage you to use some mental math and just some logical reasoning. Do you see on this one, the bottom number, the second number is 3 times as big, right, as that? Is 10 times 3 equal to 14? It's not going to be, right? So this one is clearly no. All right, this one right here, if you take a look, all right, we've got the top number is bigger than the smaller than the top. Bottom one, so that one might be a possibility. That one also might be a possibility. All right, let's take 10 over 14 and let's simplify it. If I divide 10 and 14, divide both of them by their common factor of 2, what do I get? I get 5/7. So the question is this one equivalent to 5/7? Well, do you see how 27 is not a multiple of 5, right? 42 is a multiple of 7. It's 6 times as big, but 5 does not even go into 27 evenly, so that one would be no. What about 60 over 84? I'm thinking it's going to be yes because the other two were no. All right, if it were the case, 60 over 84, well, what would I multiply? Well, this is where if you know your 12 times tables, you're in good shape because 5 times 12 is 60, and 8 times 12 is not 84. Oh my goodness, what just happened here? All right. 5 times 12 is 60. Did I write something down wrong? Oh, that's 7, Mr. Reeves. 7. All right, that's better. 7 times 12 is 84. I knew one of them had to be correct. All right, 5/7. That was what we had right here. So in this case, it was helpful to simplify, or maybe it wouldn't be helpful to simplify. Maybe you would know that 10 times 6 is 60 and 14 times 6 is 84, but that was the one that we were looking for. All right, and then when we get up into the challenge zone, does it get any more difficult? No, it's the same idea. In fact, it's easier. 20 to 10 is the same as 2 to 1, right? So we're looking for ones where the first one is twice as big. All right. 50 is twice as big as 25. 12 is twice as big as 6. 30 is half as big. Nope and nope. All right. All right, so that's an example or several examples from skill H2. Let's jump up to skill H3. Now they're asking us to actually create equivalent. So if I have, again, I'm going to write it as 1 over 5, and then I'm going to write 2, and then what is that one? All right, so here we go. The question is, what do I do to 1 to get to 2 by multiplication? Well, I multiply by 2. Do you see how that one's twice as big? Well, if I multiply the numerator by 2, I'm going to multiply the denominator by 2. So the answer we would be looking for is 10. So 1 over 5 is equivalent to 2 over 10, right? All right, 2 to 6, same idea, right? If I have 2 to 6 and I have 8 to something, the question is, what do I multiply 2 by to get 8? Well, it's 2 times 4. So 8 is 4 times as big as 2, so I need the bottom number, or the second number, to be 4 times as big. So that's going to be 24. All right? All right, let's skip up to the next level and see what they have for us. All right, same idea. We have 6 to 24, and then this time they kept the first one as the unknown. All right, the difference this time is we're not getting bigger, we're getting smaller, right? So 24 to 4, I divide by 6. So therefore, I have to divide this one by 6, and what do I get? I get 1/4. So 6 out of 24 is the same as 1 out of 4. All right? Okay. 10 to 50. Again, 10 to 50. And we have something to 5. What happened to get from 50 to 5? Well, we divided by 10. So I'm going to do the same thing here. I'm going to divide by 10, and I get 1. All right? Okay. Are we in the challenge zone? Is there a challenge zone? Why is it not going to the next level? Here we go. I knew that challenge zone was waiting for us. All right, but again, it's not really anything all that more difficult, especially if you know your multiplication tables here. Okay, the question is, what do I multiply 12 by to get to 96? Well, 12 times 8 is 96. So that means I have to multiply 10 times 8, and I hope you guys all know that 10 times 8 is 80. All right, so that's how you can do those problems. One more set of practice problems. H4. Now we got some word problems. Are these ratios equivalent? Well, all they did was add words to what we were doing before. 4 strikes to 2 balls, 12 strikes to 4 balls, okay? Now, one thing I didn't really talk about before is we've been comparing that one to that one and that one to that one. So if we did that, do you agree that 4 is twice as big? Now, I'll write it out. 4 is twice as big as 2, right? So is 12 is twice as big as 4. Is that a true statement? That's a false statement, right? We would want this to be 6, wouldn't we? So the answer is going to be no. But I also want you to know, you could also, instead of comparing strikes to balls, you could compare strikes to strikes and balls to balls. 4 times 3 is 12 2 times 3 is not 4. That shows us that that should be 6. So that's a great thing about ratios and proportions. You can compare across, you can compare up and down, all right? And then we did see also that we can do the cross product as well. So the answer to this one was no. All right, 34 to 46 and 17 to 23. Well, here's a great example of why you might want to compare this way. 34 doesn't go into 46 evenly. We can simplify this down, right? But if we were to do 17 times 2, we would get 34. And if we were to do 23 times 2, we would get 46. So both the shipments and the hours are twice as large on this one. So the answer is yes. All right, let's skip up to the next level. All right, same idea. All right. In fact, it's literally the same. 44 times 2 is 88. 39 times 2 is 78. So this ratio is twice as big as this ratio. Actually, the ratios are equivalent. The ratio isn't twice as big. It's simply 88 teachers is twice of 44 teachers, and 78 teachers is twice of 39 teachers. All right, let's skip up to the next level and see, do they have anything more challenging waiting for us? Okay, 38 to 57, 8 to 12. All right, well, here's a case where I'm going, oh, darn. Because 8 doesn't go into 38 evenly. 38 does not go into 57 evenly. 8 does not go into 12 evenly. All right, so this is a case where maybe I could simplify this one down. Do you agree that I can divide both of these by 2? All right, if I divide both of those by 2, half of 38 is 19, right? And half of 8 is 4. So why does that help me? Because 8 doesn't go into 12, but 4 does. So I'm going to write that bottom one down again. And then I'm going to say, hey, take a look here, Mr. Reeves. 4 times 3 is 12. Is 19 times 3 57? All right, well, you probably haven't memorized your 19 times tables, but you know that 20 times 3 is 60, right? Take off 1 each time. You're going to go from 60 to 59 to 58 to 57. So sometimes simplifying one of the ratios or both of the ratios can really, really help, all right? So if we divided this one by 3 and we divided this one by 2, we would get the same ratio. The answer is yes. All right, it's not going to let me go any higher, so let's do one more problem like this, and then let's call it a day. All right, 531 in 893, 207, and 316. Again, I'm not seeing these go in evenly, so I'm going to ask myself, can I simplify these? And these numbers are a little bit more challenging as I take a look. All right, none of these, only this one is even. These aren't even, so I'm not going to divide by 2. Maybe I can divide by 3. All right, so 3 into 531. Well, let's take a look here. 3 goes into 5 one time. Bring down the 3. 3 goes into 23 7 times. And 3 goes into 21 7 times. So that simplifies to 177 per. Now I'm going to divide 207 by 3. By the way, have you ever learned the trick to know if it's divisible by 3? If you add the digits together, if they're divisible by 3, the number's divisible by 3. So if you're wondering, does 3 go into this number? Well, 5 plus 3 is 8 plus 1 is 9. Since 9 is divisible by 3, that means 531 is divisible by 3. Same thing here. 2 plus 7 is 9. So I know that 3 is going to go into this evenly. All right, 3 goes into 20. 3 times 6 is 18. Subtract that. I get 27. 3 goes into 27, and I get 69. Okay? All right, now if I do this one right here, Is 3 going to go into this number? It's not, is it? All right, because 8 plus 9 is 17, and 17 plus 3 is 20. So 3 is not going to go into this evenly. All right, the question is, will 177 go into this evenly? And if 3 doesn't go in and 2 doesn't go in, I'm wondering, maybe does 7 go in? Is there a way to do this? All right, so let's go ahead and try. Let's try and see if 177 goes into 893 evenly. All right, so 177 into 893. Well, if I rounded this up to 2, 2 would go in. We could try 4, right? Well, 4 times 7 is 8. All right. That's not gonna work, is it? How about if we tried 5? 5 times 7 is 35. Carry the 3. 5 times 7 is 35. I get 8. Carry the 3. All right. And that is going to give me 8. It's not going to go in evenly. You know what? This answer is no. Alrighty. Okay, that was probably the most difficult one. We didn't have to use a calculator on any of them. That might have been one that maybe getting out a calculator and doing some work might have been appropriate. Certainly not for this last one here. I know I said that was the last one, but I want to finish strong on this one because here's one we definitely should be able to see, right? I can just get rid of these zeros. I just divide it by 1,000. And the question is simply, is 6 over 4 equal to 9 over 6? All right, so here's a case where, hey, if I do that cross multiplication, 4 times 9 is 36. 6 times 6 is 36. That's a quick way we could have done it. We could have taken 6 over 4, and we could have divided both of those by 2, and we would have gotten 3 over 2. And then we know that if we multiply 3 by 3 and 2 by 3, what do we get? We get 9 over 6. That's another way we can confirm that it is yes, right? We also could have drawn the pictures, right? And we have 6. 1, 2, 3, 4, 5, 6. And we have 4. Actually, let me do this. All right. I'm going to separate these 6, right? And then we have 4. Do you see that right there? That's 3 and 2. And if we do one more set of those, look what we have. We have 9 on the top and 6 on the bottom. I just wanted to quickly go through the different ways we can prove that those ratios are all equivalent. Of course, I left off the multiple of 1,000 because that would be a lot of dots to be drawing. Okay, well, I'm going to let you guys go ahead and work through the challenge zone. All right, I hope this was helpful. Have a great day. Until next time.